recording or no? Yeah. So when we look at this, I did not hear the beep. I think I have my volume down. Whatever belongs within that circle or rectangle, whichever one it is, it belongs in that group. So when we look at like this natural numbers one, this is the, and you've done a lot of these before, not necessarily all of them, but natural numbers are basically 1, 2, 3, 4, 5, and 6. Zero, before anybody knew and understood zeros, before anybody understood negative numbers, fractions, so on and so forth. These were the very initial numbers that people used to count. Right? Those are natural numbers. Well, natural numbers are also enclosed in this rectangle here, right? Come on, you. Not working. I have 3. I think they all need new batteries is my problem. And when I'm using them, I want to order them. But I obviously don't want to do it during class. And then after school, I don't think about it. All right, there you have the whole numbers rectangle. That just adds in the 0. But since the naturals are still within that rectangle, those are still considered whole numbers. Then you have the big integers, oval here, integers, add in fractions. But since natural numbers are still in there, whole numbers are still rational numbers. Okay, so you've seen this before. You've seen flowcharts like this before. What we're really concerned about is, notice, let me erase all that. Let me box in the 2 that we are concerned about. This here big rectangle is rational numbers. Notice how that is clearly different than this big rectangle here, which is irrational numbers. There is no overlap with those 2 categories. All right, we agree with that? That's what we're kind of focusing on right now, and what types of irrational numbers, what they are, what they mean, so on and so forth. We give them to you. I do want to add a little note in here. So kind of go off to the side here and let's define each of these. So put rational. Let's make sure we kind of understand all of those. So again, rational number is this big rectangle here. So rational numbers are your natural numbers. So natural, your whole numbers, integers, all that good stuff. What we really want to focus on is what they also are fractions and decimals, and specifically decimals that do one of 2 things. They need to either terminate. So a decimal that terminates is like 1.5. It just stops at 5. Or 2.65. It just stops at 65. It doesn't go on forever. Or it repeats. So the big thing at some point in your life you've learned, so if I kind of give you an example of this, remember if you get like 0.3 and you put the little bar over the top of it, you know how that repeats over and over and over and over again? As long as it's a decimal that repeats like that, or it just ends eventually, that's a rational number. It can be written as a fraction. Those are kind of the things you would have talked about before. So the decimal terminates like 1.5, it just stops, or it repeats the same number over and over again. Versus irrational numbers, because you haven't dealt with most likely, I don't think you deal with irrational numbers much in the past. Irrational numbers, the big irrational number, you've seen and heard about pi before, correct? All right, that's the most common, well-known irrational number because it is a decimal that never ends and never terminates. It just goes on forever and ever and ever and ever without any pattern whatsoever. Now, we haven't dealt with pi at all. We're not going to deal with pi anytime in the near future. Irrational numbers for us, so what I want you to put is when we take the square root. So notice this box here, right, where it has the irrational numbers. Notice all those square roots here. These are when we take the square root of a non-perfect square. Because when we do that, I probably should have wrote this first, so sorry. These are also going to be decimals, but whereas rational numbers either terminate or repeat, irrational numbers do not terminate. like pi, right? This just goes on forever, so it doesn't ever end, and it does not repeat. So again, look at the number for pi. It just goes on forever and ever and ever. So the big ones, the reason we're talking about it right now is if you look at the numbers enclosed in that rectangle, see how there's a root 2? That's an irrational number. And the reason it is irrational, if I throw it into my calculator, I kind of did it already first period, but if I do the square root of 2, 2 is not a perfect square in our list. If I hit enter, notice how this is a random set of decimals that never ends. And the only reason it looks like it ends is the screen ends, but that would go on forever. Is there a pattern to this at all? No. So that's why it's irrational. I gave you, root 3 is in here. So if we go to calculator and I do the square root of 3, notice how this is a decimal that never would have ended other than the screen ends. And is there any pattern to that repeating? No. So those are irrational numbers. So whenever I take the square root of a non-perfect square, those are irrational. And it produces a decimal that doesn't end and doesn't repeat. That's what we're going to do in these first couple of questions. We're just going to identify, are these numbers rational or irrational? So number one, we did these yesterday. Did I? No, I didn't grab your homework, did I? Okay. Let me get your homework real quick. Pass that in. Pull that out. Make sure your names are on those. Don't let me forget to record again, Ms. Krubas. I'm going to pause this. So if we look at these numbers, we just want to identify are they rational or irrational numbers. So the whole point, what me remembering that I needed to grab the homework, is that this is what you did last night for homework. So if I gave you this problem last night, what we talked about is since both of those are underneath the square root, all we really do is take the square root of both of those. So the square root of 25 is 5. And the square root of 49 is 7. So a rational number is basically any number that can be written as a fraction. Notice how this is written as a fraction. That's a rational number. All right. When you look at 2 now, really what we kind of focus on is the decimals and do they repeat, do they terminate or not. So when we look at 6 or number 2, you get 4.6, 5, 3, 8. These little dots just indicate that this does go on forever and ever. And that's okay. It can be rational as long as it repeats. Is there any pattern or any number that's repeating over and over and over again? No. So it doesn't end. It doesn't repeat. That is by definition then our irrational number. All right. When we do these, we also want to simplify them. So like 3 by itself is irrational. Like if I think I plugged that one in, it's an irrational number. 12 by itself is irrational. But if we actually multiply these guys together, and this is what we quizzed on, and you'll get those quizzes back here in a little bit. That's how we would multiply them. Anything underneath gets multiplied. Anything out in front would get multiplied. Then isn't this a nice number? The square root of 36 is 6. That makes it a rational number. It's not a decimal that never ends. It's basically 6.0. So that's a decimal that terminates. All right, that's our rational number. 4, when we multiply these, you're going to do the 2 multiplied by the 3, since those are the numbers out in front. And that's going to give us a 6. And then we do the numbers underneath the radical, and then keep those underneath the radical, which is a 15. When we did number 3, we got a nice perfect square under here, and that was equal to 6. Is 15 a perfect square? No. Could we break it down any further if we wanted to? Like, are there any numbers that, yeah, we can use 5 and 3, but are 5 and 3 a perfect square at all? No. So this is, if we again look at our little chart up here, anytime we get a perfect square that is not a perfect square, those are irrational numbers. So the square root of 15 is definitely irrational. And again, I'll show you that just to make sure we understand what that means. If I did the square root of 15, notice how there's no pattern to this. And the only reason it stops is our screen ends. It would go on forever and ever and ever. All right. Okay. 5. Write down what do you think for 5. You now have the little bar over the top of it. Okay, what do we think? Rational or irrational? Rational. Why, Sage?
Because it's repeating.
Good. It's just going to repeat this 4, 5, 4, 5 over and over and over and over again. So as long as it's repeating, that's a rational number. Okay. All right. Number 6, if these can be simplified, we want to simplify them. So this is really a negative 6 times a 2. The root 4 is a perfect square. That negative 12, that then is nice. So definitely a rational number. All right, 7. Write down what you think for that one. That's a decimal. Is that a rational decimal or is that an irrational decimal? All right, Maria, what'd you write?
It's rational.
It is rational. And how did you know that?
Because it like stops.
Good. It doesn't go on forever. So it just stops. It's 9.75. The decimal is finished. That then tells us that it's rational. Okay. Last one, like number 1. Or number 2, I think. Yeah, number 1. If we can divide these, you could do that right off the bat. So that 27, 5 over 49. It's the same here, except this one. We could, if we wanted to, take these square roots, but does 2 go evenly into a 16? Yeah. So this is, again, from yesterday. We did a few of these yesterday. We can just write this as a root 8 right away. Is root 8 a perfect square? No, that means it's irrational. As soon as we're taking the square root of a number that's not a perfect square, that means we are irrational. So the last one of these, if I plug in the square root of 8 into the calculator, watch how there's no pattern, and it just goes on forever and ever and ever and ever. Okay? So those are our irrational, rational ideas. Okay? All right, so now, that's hopefully not too bad. These are going to be a little tricky. These get a little bit sneaky. And it's called the square root method for solving some quadratic equations. So it says to solve a quadratic in the solve quadratic equations or cubics in the following form. So what a quadratic is, these are our parabolas. So remember, it's going to look like this: x squared, and it's going to be set equal to some number. So if we're in that form, that's a quadratic. It has a power of 2. We spent like 5 weeks on it. We took a test on it, parabolas, all that good stuff. Yeah. Oh yeah, thank you. Let me make it a little smaller. It's pretty large. Yes. All right, we could also get cubics. We can also get, we'll see one here probably tomorrow with a power of 4. Or if we get like a cube set equal to another number, things like that. There's a lot of different versions of these. When we do these, the first step is to always isolate this. I'm going to put square just because there's a lot of different versions of this. We're going to isolate the square term. All right, we'll show what that means here on the next page. You got a whole bunch of these coming up here. But we want to get that square term by itself. Once we have it by itself, the reason we want to have it by itself is we want to eliminate the squared term. Right, we want to actually eliminate the squared power. We'll put it that way. So we isolate it, and the reason we isolate it is so that we can then get rid of it. And then the third thing is you solve whatever equation now remains. All right. Sounds simple enough. These can be a little tricky. What I want you to do as people are copying this on, once you get this copied down, go to the next page, answer number 9 with no work, just some common sense. Just, you're all good, solid math kids. Look at number 9 and tell me what x would have to equal. Isn't it 9? Oh, got it. All right, do we all have this down? Can I, Yusuf? We're all good. You got it all, Yusuf? All right. All right, so if I look at this one, don't say it yet. Pretend like you didn't hear Jackson. If you didn't, then solve that real quick. Tell me what x would have to equal here, and write down what you think this answer would be. So what we're just thinking, the reason we hopefully can do this one in our head, is we're thinking, what would x need to be right here so that I can square it and get a 25? What did you say, Jackson? Good. So x would be a 5. All right, do we all agree with that? All right. Anybody want to add anything to that? Say something differently? You sure? All right. Then let me give you a prompt. There's another answer. So now give me the other answer. Don't say it out loud if you think you can figure it out. Because now we should all be thinking something different. Okay, we're getting some hands up here. You got it, Maria? No? All right, I saw Sarah first. So Sarah, what do you think, Sarah? All right, Sarah says -5. So now let's test that. If I plug in a -5 and I square it like I'm supposed to, would that also give me 25? Yeah. So these are both your answers here. All right, 5 and -5 are both our final answers. Also, real quick, think back to what we tested on about a week and a half ago. I actually gave you this before. It's a similar type of a question. Remember how we said we want to set this equal to 0? And we did that little 0 product property. So you don't necessarily need to do this on yours, but just kind of pay attention how this worked before and how it's going to give us these same answers. Remember how we said we always wanted our equation set equal to a 0? So if I did 25 minus 25, those are going to cancel. If we look at over here, these are not like terms, so we can't combine them. So we would just get x squared minus 25. Some of you actually are retaking this test in the process right now. Let me move this over a little bit. And then remember how we would factor these? Remember how we called this guy a difference because we're subtracting? And then aren't these both perfect squares? And we would have factored this to be x minus 5, x plus 5. This is vaguely familiar. We just took this test 2 weeks ago. Okay, it's coming back to us a little bit. And then remember how I would ask you, what x value makes this factor a 0? So what x value does make this factor a 0? 5, right? Isn't that one of our answers? What factor makes this one a 0? Yeah, -5. Isn't that an answer? So this is a different way of kind of solving these equations. And we do that, all right, with the idea of the squares and how we're going to be able to do it. But we should still get 5 and -5. Okay. I'm going to add some problems to these. The sequence of these that we have chosen, I don't necessarily love. So go down to the bottom of the paper, put 23, and just show me that you understood what we just did, and tell me what the answer to this question is. All right, now there should be not a lot of work. There should be nobody confused at this, hopefully. Maria, what's one of our answers? 10, because 10 squared is 100. And then Hannah, what is our other answer? All right, we all agree with that. I can do 10 and -10 squared, and I want to get 100. So there are 2 answers to these. All right, last one that I'm going to add, at least initially. Answer this guy for me. If I give you x squared equals 64, tell me what that answer is. All right, Yusuf, what do you got? All right, we all agree with that. Okay, so we all agree these are giving us 2 answers right now. Okay, so now go back to this number 9, because here's what our steps are telling us to do. It says to isolate the square term. In the first 3 that I just did with you, those are already isolated. So now let me kind of erase the way that we did this before. So notice this square term is all by himself over here, which is good. The second step that I told you to do is eliminate the square term. We want to get rid of the power of 2. Well, the way we get rid of that We've talked about this. The way we get rid of squares is with square roots. Square roots and squares cancel each other out. So when I take the square root of a square, all I am left with is the number underneath, which is an x. But if I do that to one side, same old algebra rules, I've got to do it to the other side as well. We just did 3 of them. So the biggest part of this that people are going to forget, so don't be one of these people, because I'm telling you right now it happens. We all understand that there's 2 answers to this, correct? So when we do this, we have to put, you've all seen this little positive negative symbol at some point in your life. When we take our own square root, we have to put that little plus minus sign in front of it. And then what is the square root of 25? 5. Doesn't this give us both a positive 5 like we got here, and then the negative 5 is telling us we also get a negative 5. So whenever we take the square root of that number, always, 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 we put a plus minus in front of it right away. Okay? All right, so those are the easiest, simplest. You don't even really need to do the work. We could do those in our head. Now, if we go to number 10, now we add a little layer to this. This is still not a bad one. This is actually a fairly nice one. If I now tell you to solve that equation, now we do need to do step number 1. So step number 1 is to isolate that square term. We don't have that done yet. So if I now told you to solve this equation, let's pretend the squared, don't cross yours out, but let's pretend on mine this isn't here. Do the first step. We would all know what to do, right? So do that first step if the squared wasn't there. All right, and Julia, what are you doing right now? What is the first step? Good. You would subtract 5 from both sides. That is still your first step. So those are going to cancel. We'd still have the 2x squared on the left, and we get 18 on the right. All right, so nothing different than what you would have done for the last few years. And this next step, again, don't cross yours out because the squared is definitely there. But if that wasn't there, do we all agree you just divide by 2 at this step? So same thing here. Now the squared is here, so let me make sure that that's there. You make sure that yours is there. But I would just divide this by a 2. So don't we now get x squared to equal a 9? Doesn't this now look like the first 3 problems that we did? This is one we could do in our head, right? Isn't it 3 and negative 3? We know that pretty quickly. But show the work for this just so we understand. I now take the square root. That means I have to take the square root of the other side. And when I take that square root, you have to put the little positive, negative symbol in front. We then get the square and the square to cancel. So that's going to give you x, and we get both a positive and a negative 3. That actually gives us 2 different answers, positive 3 and a negative 3. That's it. All right. All right, we follow that. Okay, again, I don't like the order in which I have this. So go to the bottom and add a 25. I got to remember what I thought on my feet on the other one. So do this one and show me that you understood what we just did. This is a 4 here. So add that guy and solve that one. Yeah, I added that one, so add that one to the bottom. The sequence in these I wish I had a little bit better. All right, if you go all the way through that and you get 5 and negative 5, then you did it correctly. Is that what we're coming up with, hopefully? All right, Fabian, what do we do first then, Fabian?
I did subtract 4.
Good. We want to get that x variable by itself, so we're going to subtract 4 from both sides. That gives us 50. And then what?
And then I divided by 2.
Good. Divide by 2. So those are going to cancel. X squared equals 25. This, again, you could probably do this in your head. Those first 3 that we did, we can figure it out. Isn't it 5 and negative 5 squared to get to 25? But if we actually follow our rules, because we're going to have to do this in the next one, we take the square root of both sides. And when we do that, do this in a different color here. You have to put the little positive, negative in front of it, and then that gives you a positive and a negative 5. And that's what this is. Okay? All right, so hopefully we're still thinking this isn't bad. This is easy. So now go back up to number 11, and now we add another layer to this. A little sneakier. First step, we want to get our square term isolated. So here's your square term. Notice how this whole thing is underneath or raised to the power of 2. So that whole thing is your square term. So that guy is done. It's already all by itself. Your second step that we've been doing is once it's isolated, we want to eliminate it. And the way we eliminate that squared power is with a square root. So go to number 11. That's what we're prepared to do right now. We want to eliminate the square root or the square with our square root. So take the square root of the left-hand side. The square root and the square cancel each other out. That then means all we are left with is what's underneath, and that is an x minus a 4. All right, so whenever we take a square and a square root, these guys are effectively just canceling each other out, and then all we're left with is whatever's underneath. Well, you've been solving equations for a long time, and you know whatever we do to one side, you've got to do to the other. So I also need to take the square root of the 36. But now that new little part that we kind of discovered and showed at the beginning is when I take that square root, I better also have a positive and a negative in front of this. Because we don't get just 6, we get both the positive 6 and the negative 6. All right, follow that. Now what we have is 2 different equations here. All right. So what this really means, I think I'm going to do it this way. This Pyramus Kublitz is x minus 4 needs to equal a positive 6. That's one of our equations. But we could also do x minus a 4 equals a negative 6. It has to equal both of them. All right. Notice now how we have these 2 equations. So now we, for the first time, have to do this third step, and that is now solve whatever equation that results in. So now we need to go through. If I ask you to solve this equation, don't we just add 4 to both sides? And then that would give us 10. So that's one of our answers. If we go to the second equation, add 4 to both sides, our second answer should be a negative 2. What you should notice first, and the people get programmed to think this, they just think they always get the same number, but one's positive and one is negative. Are these the same number? No. So don't think that's always how these answers are going to look. Then let's just prove this real quick. So whenever you would have learned equations back in the day, shouldn't I be able to take 10, substitute this in right here, and make the left-hand side equal to 36? So let's do that. If I did 10 right here, what's 10 minus 4? 6, and what's 6 squared? Is that 36? Yeah, so that's definitely an answer. But the other one should also work. So if I now take this negative 2 and plug it in, what is a negative 2 minus a 4? What does that give us? Negative 6. And don't we know that a negative 6 squared would also give us this 36? All right. All right. So again, sorry, I'm going to add another problem. So go to the bottom and add a 26 and show me that you can solve a question like that. So let's do x plus 7 squared equals 81. Solve that for me. So add that to the bottom, make that a number 26, and see if we can do that. And if you want to check, take those two answers, throw them into the equation, and it should work. Alright, good. All right, Riley, what'd you do first?
I did x plus 7 equals.
Okay, good. So the way she got that is she took the square root of both sides. The square root cancels out that squared, so that's why she said x plus a 7. We're definitely going to get the 9 right here, but we, again, have to remember this. When we take that square root, it has a both positive 9 and a negative 9 that we could have squared to get that. All right. That then gives us our two different equations. One equation is going to be when x plus 7 gets equal to the positive 9. And then this also sets up the equation when x plus 7 gets set equal to that negative 9. All right. Then we now have the third step with these where we're going to solve these. What was your first answer, Riley, here? By 1, you mean 2? Good. So x equals 2, 9 minus 7. Good. All right, and then the second one, subtract your 7 over. So if you got 2 and 1, what was our second answer? Good. And negative 16, you did that correct. All right. Did you get that one right? That's the hard one. Yeah.
All right.
Good, Riley. All right. So that's how we would do those. Let me show you one last type, and then we'll probably stop and do the rest of these tomorrow. So now go to number 12. And then this is where it gets a little weird. All right, number 12. This looks just like the previous two. We are ready to take the square root of the left-hand side. It's all by itself. So go ahead and do that. Take that square root. The square root's going to cancel out your square, leaving us with this x plus 3. Just like you did in those previous couple of questions. Actually, walking around, a lot of us were getting that perfectly fine. So we also would then know, because we just did that previous problem perfectly, we also need to do the square root of the right-hand side. And when we do that, we're going to have a plus minus in front of this. So now tell me what that would equal. And don't give me a decimal. What's this then, Henry? What's the square root of 49? Yeah, so is the square root of 54 a 7? Nope. That's actually really good. That back when you would have learned square roots at some point in your life, your teacher actually would have had you like estimate them. So yeah, root 54 has to be in between 49 and 64. So it's 7 something. So yeah, that's good. That's good thought. All right. What I'm getting at is this a perfect square? No. So unfortunately, you can't write down a nice whole number here. So what we're going to have to do is what we just quizzed on, and that is we need to simplify that. What two numbers will work to give us 54 with one of them being a perfect square? What was it? 9 and? Good. So 9 and 6. So what we now want to do is have that x plus 3 set equal to, then we'll still have our plus minus, but then the square root of 9 is a 3 root 6. It's going to look weird. We haven't done anything different now other than that's not a perfect square. But you're going to set up your two equations again at this step. So you're going to take x plus 3, set it equal to 3 root 6. Oops. Move this over a bit. So that's one of our equations. And you're going to take that x plus 3 and set it equal to a negative 3 root 6. Now, the difference with that, once we have that set up, when we did these down here, when I subtracted the 7 over, couldn't we combine these because they're both regular old rational numbers? So we can combine those. That's a 2. This is a negative 16. But now when we look at these, when I do this next step and I say minus 3, yeah, these are going to cancel. But again, this is what we just quizzed on, so we got to kind of remember all of that. These are not like terms, right? One is a radical, one is not. You cannot combine those. So you just have to write this as 3 root 6 minus a 3. It looks weird, but that's how we would write that answer. We still have the second one as well. We're going to subtract the 3 from him also. But since this is a radical and this one is not, we cannot lump those together. We just write it as a negative 3 root 6 and then minus a 3. That is your second answer. And again, looks really weird. Okay. All right. I think we're going to stop there because I want to get the quizzes back and the homework back from yesterday. And then I want to have some tomorrow to review so that we can then do some homework on all of this tomorrow. So today you don't necessarily have any new homework. I'm going to give you back the homework you turned in yesterday. And then if you think you need to do quiz corrections, that's your homework. I need these for tomorrow. All right, so if you're not happy with your grade, that's your homework. That was the old one.
In 10, you know how many hours it was? You leftovers, put it back in
Six. No, this is your homework. Quiz is next. Quiz is next. What was it? And here comes the quiz. Last.
How come Coach Bale's tweeting yet, right?
No,
How come Coach Bale's tweeting yet? He's usually on top of it.
I know. He only posted for Instagram.
You can.
Yeah, Instagram.
Yeah, anybody can do the corrections. It's
Oh,
open
have
to
you seen
anyone.
it? Oh.
In fact, if you only miss
my
one or
gosh,
two,
I
you
like
can,
it.
you're done.
He posts everything on
If you
this.
can figure it out, you're done in 2-3 minutes.
Doesn't have Slack. Do you have a Instagram account for cross country? For what? For cross country.
For what?
Instagram.
It is. I don't really use it though. Except for everything else.
Look at this was Vale's house last year when we destroyed it. It is so bad this year. We have so much stuff. We're doing it tonight, but he is working. Like yeah, just a bunch of that's my punctual that lost, but didn't get last place. But he just puts like a bunch of someone like Claire Haley. This is a mess.
Yeah.
Yeah, they would be thrilled.
I hate taking pictures.
Put one on the broken part.
So I did it for Twitter. I gotta find something new for this year because she graduated.
Have Maria do it. Well, you could be in charge of the girls' start the Instagram.
No, you don't want that responsibility.
No, that's too much. Tell Riley to do it. I don't know what even. We could like take action shots on this. Should I come to show you?
Yeah.
I taught her to practice take some cool shots. You know what I should do? I should like TikTok for slow mo. Yeah, and that would be so cool. And then post it on Instagram. Yeah. That would be like first home game come. Dude. I'd be so good.
What do you think?
Okay, that should be all of them. So again, if you want to have some extra points back, sit down, figure out what you did wrong, turn it in tomorrow. If you have questions, let us know. 2 minutes now, or just come in early real quick if you need in class. If that's where we're at sometime, let us know. And then should not be great either way. Okay. All right, so that's it. No homework unless you want to do some corrections.
See if I go once you create an Instagram account or something, run it.
Do it.
It's the last thing I need.
Will want to. I'm upset that Maria doesn't want to. I'll do it with you guys. Like, I'll just.
That's the last thing I need is another anything to worry about.
Yeah, last year.
You might have a next year.
Get rid of the login.
Yeah. Yep. I don't blame you.
Oh, yeah,
I hate posting. I don't think about posting.
Janine does all of our. So she, if you go through my page, most of it is Janine taking pictures. And then, so that's she's the picture taker at our meets and practice, and then she'll post it and just retweet it from there.
That's good.
Yeah.